Okay, now we have 57 here. So, okay, let's get this question number 3AB, like I have mentioned it to you. Make sure you go through it, because in case one question gets added up on LSA, because somebody may think that LSA weightage is too low, then the question will get added up. In case it gets added up, you should be able to score on this. That means you may get 2 questions on LSA. Then 4A is elementary level, fire, triangle, quadrilateral, explain different parts of it, etc. Spontaneous combustion normally will go not for 5 marks, but most probably it will be in question number 1, where it will be carrying 2 marks. Limits of flammability, you should be able to draw the diagram to explain it. Like ULI, LFL, like what is that? Low range, high range, limits. This all you should be able to explain. Too rich, too lean. Lower points, higher point. In between it is explosive. So that is the explanation you will need. And that diagram is more or less straight. 1 parabola, 1 straight line, 2 scales. And then you will just mark. And I'm quite sure you will not make that mistake of saying oxygen is 21%. It is oxygen basically in atmosphere is 21%. When we start dealing with fire, then we start looking at the percentage in that explosive gas, how much is mixed with the flammable content. And that is where we look at in this diagram. So there is explosive limit. So this is what you have to explain. Then the standard ones, advantages, disadvantages of all 4 mediums. This is mugging up, no big issue, but advantage, disadvantage. You should be able to have a table, and you should be able to compare 2 mediums. Classes of fire, we have got. Now what happens is IMO did enter in it, but did not really stick much to it, because what happens most of the time, fire is, shipping is a very small thing for most of the countries. The damages by fire are much higher on land. So they have got much more specialized I will say organizations who deal with this. So they have defined in their way. So there are, like ISO has been mentioning it. Other countries have got their own standards. So that is how they discuss. But anyway, your main classes are A, B, C, D, and F. Now, ABC is very much defined in your syllabus. So this is a very specific question coming directly from the syllabus, is how do you deal with class A, class B, class C fires. Then we move on to the 4B. This is mugging up. 5 safety, safety objectives and functional requirement. This is also mugging up. Class A60 bulkhead you should be able to define. Now, general mistake is the people don't mention stiffening. They say, okay, steel or equivalent material, but they must be suitably stiffened. And then additionally, there is a flame and smoke. Both are blocked by A60. B, it's different. B talks only flame, not smoke. So this is the difference. So A, you know well, you are okay. Control station, again, it is a list of equipment, what all is monitored from control station. Normally, control station is navigation bridge on normal cargo ships, because it is manned 24 hours when you are at sea. Passenger ships, it is possible it is somewhere else as a specialist job. Like passenger ships, you, instead of giving it as a part-time job to people like us, who basic function is navigation and other things. You can have fire experts who will be taking care of fire on board, like fire brigades. The training is much more like, in I believe there is a course in Nagpur or somewhere. It is a graduation course, 4 years course on firefighting, 4 years full-time course. So obviously the expertise levels will be different. Escape route is a standard known one. Now escape route, when you describe, the dimensions do vary between passenger ships and cargo ships, but what you need to mention is the minimum weight. Even if you get it little bit wrong here or there, it's okay, but at least you mention the minimum weight. And more important are like doors, en route, lighting, rails on the ladders. All those points are more important. Escape route is also protected by class A60 bulkheads. Okay, so the markings and all. This is how you will cover up at least 5 points with description. Cargo tank venting system on a tanker. We are going to mention mass raisers, then PV valve system. What happens is, if there is a vacuum, which is always monitored, if there is a vacuum, you feed extra inert gas. You start the plant and feed in extra gas so that it comes to the normal, it balances with atmospheric pressure. Whereas if there is a high pressure inside and you have to vent the pressure, in that case, that pressure what you are releasing has got hydrocarbon contents along with some oxygen, along with inert gas. All three are combined there. Your inert gas has got less than 5% oxygen. Now, when you release the mixture, you will have hydrocarbon gas gets released in the atmosphere. Atmosphere means suddenly there is extra oxygen is there, and if there is any source where a spark can occur or anything, whole thing will catch fire. So there is a specialist system, and when you mention this, you will have to mention how it shoots out. The escape velocity should be 30 meters per second and so on, so that it doesn't catch the spark. Plus the spark arresters are provided. It is away from the accommodation or sources of ignition, and it has got height which is much above its height is about 6 meters, so that normal person will not get hydrocarbon gases in his lungs. Okay, and this probability of ignition is reduced on ships. Means you have got certain answers there. That first thing, no smoking only in designated areas, you don't do hot work wherever you feel like, and so on. So when you get a question like this of 5 marks, what you need to do is you ensure at least 5 points should be there. And again I keep on repeating the way I was repeating in the class. Do not use Roman numbering system. Use normal numbers like the way I have got it here, 1, 2, 3, 4, 5, 6. That's the best one. The reason is, when somebody is correcting your papers, why do you want to test his knowledge about Roman numbering? You may be very good at it. So it is like, if I start talking to you in a language that you don't understand, then I force myself to understand you. So my counting may not be right, and then I may not count. Generally what happens is, when paper corrections are done, people also look at number of points. Okay, so mention the similar numbers, so that when I look at it, okay, this guy has written 7 points. All of them look okay. Okay, let's give him 5 marks. Whereas if you just put it as a dot or asterisk, I have to count 1, 2, 3, 4, 5. That means you are irritating me for nothing. So that is where those 5 marks in the end land. Don't irritate me. Generally, you will get those 5 marks as for good behavior. If you irritate me, automatically hand gets tightened. Like when you are writing answers in exam. First, go on your strength. What you know the best, first put that, so that his initial impression is created. And then rest of the paper will be corrected. I agree, means whether it's fair, unfair, I'm not going to discuss that. I agree that it may not be that fair. But what happens is, our examination system is based on descriptive answers. Descriptive answers means the control comes to me, how many marks to give. If it is a problem, yes, every point is considered. This 1 mark here, 1 mark here, 1 mark here, 1 mark here, like that. Whereas all our answers are not like that in this paper. So in the end, the guy who is correcting paper has got, you can say, up to 5 marks, plus minus. So if I correct it and somebody else corrects it, we can have a difference of 5 marks anyway, and both are right. What I am looking at it, with the way you write, I should be impressed when I start that yes, guy knows this subject. Your presentation is good. Your points are mentioned properly, like 1, 2, 3, 4. I can read clearly. I can mark. No problem. So what happens is, when I come to your weaker areas, I am already little softer. So if your answer deserves 2 marks, I may give you 3 marks, 3.5 marks, 4 marks. Why? Because I see a guy knows well, ek chota sa ek galti ho gaya, never mind. That is how most of the people will think. But okay, it depends on the person. Then we come to the Phi. Phi AB is put together because the part of the chapter you are going to get 1 question, 10 marks. Here basically we are teaching about the fire detection, safety precautions. Now, like fire detectors, different types are there. You should be able to compare them, and that is what we come here also. Compare the smoke detectors and the fire flame detector, heat detectors. Then you have got in heat detectors, 2 types of heat detectors, ionization principle, or how ionization works. So if you draw anything, any one of them, if you have to discuss or you have to draw one type of system, so mention this word. If you are using ionized, mention ionized, where most of them are ionized anyway. And once it is ionized, it has got shelf life because there is a radioactive element in it. So these are the points. When you mention, automatically it shows your knowledge level. Then write note on addressable and collective fire system. Collective ionization means we use a radioactive element. Now this is a query, somebody has got. So ionization means we have a minute, minuscule amount of radioactive element in it, which keeps on giving the ion. So the circuit is always complete. And when that circuit gets disturbed with higher amounts, the alarms will be activated. What happens is, if I don't have a circuit complete and I have got an open circuit till something comes and joins it, the reliability is low. This is the reason ionization came in. Otherwise, what happened? I had one old-fashioned strip heat detector till it bends. How do I know it is working? Reliability could not be given. Yes, that is exactly. Now, this is why I said that if element gets completely used up, that is the shelf life. Shelf life means valid for 2 years from this date, because in 2 years from this date, the element will get used up to a level where it will not be reliable. It will never be zero. It will still be there, but it will not be reliable. So that is the shelf life. So every one of the detectors, what you will find on the ship, you will have some date there. That date is telling you when it was manufactured, manufacturing data, from date of manufacture, just the way we have got masalas, everything, same shelf life. So that is it. Is it clear now? Okay, good. So this is what. Now again what happens is, this chapter, these 10 marks are also relatively easy to get because straightforward on detection, and this, all the detectors you have done. Ionization principle, once you know it, it becomes same for everything. Whether it's a smoke detection, whether it's heat detection, this, that, and you will be able to apply it, all of them. Because you see, we use hardly any percentage of detectors, means the way they are manufactured. You go to every hotel, every office, and nowadays homes, you have got detectors everywhere. So the technology has advanced a lot. We use the most advanced technology, which is reliable and certified. We don't use something that is on trial basis. Ours is always proven, tested, and then only applied. Then you have got question number 6 and 7. 6 and 7, again these 20 marks. We are talking about now here. 6 and 7 is basically different types of extinguishers. Either they are portable or fixed. So again the same mediums are coming in. Like you have got water, foam, DCP, CO2. Now 4 extinguishers straightforward. Okay, you should be able to, and CO2. 4 only, correct? 4. So these 4 extinguishers, you should be able to draw the diagram properly. Please don't try to draw crude diagrams. It's not difficult to draw an extinguisher. All you need is the 2 parallel sides, cut-off base. That means you are drawing a rectangle, vertical rectangle first, then the top part, you round it up, and then put a cap, and then you show the hoses. It doesn't take time. You have got more than enough time in exams to draw proper diagrams. Right now, I will suggest draw few of the, see, any one type you draw, rest of the things are internal. Basically, when you draw something, things are internal where you are showing the cross section, but the outer shape more or less remains same, and the top part will vary little bit. So there is no reason, and one question will be always there on this. Then you have got to draw block diagrams and explain the same mediums as a fixed mediums for firefighting, fixed extinguishing system. Like CO2 system is there. When you come to CO2 systems, any fixed systems has got different alarms. You must understand those alarms. You should be able to mention these are alarms on the system. Even if you mention few, generally guy knows what you are talking, means your knowledge is good level. You will get full marks. When you come to sprinkler system, hyper mist system, both are similar. Pressure difference is there and small difference in operations. Sprinkler is automatic, hyper mist is manual. You need a special permission to put it on auto. All the fixed firefighting systems except sprinkler system are manual, and you cannot put automation on this without proper approval, because the danger involved is the false alarms which get generated. No matter what happens, there will be few false alarms, and that time you don't want things to get activated, killing somebody. Because, for example, CO2, enclosed spaces you are going to use it, people may be there and you will release CO2, so that is not acceptable. Hyper mist, the problem that you can get with hyper mist system even though it is not going to hurt human being, but it may cause short circuits. The reason being, when you are at sea, no matter what happens, there will be minute salt content in atmosphere, which is going to get deposited on all the surfaces. It is there, that minute salt percentage is there in the air, so ventilation will carry it everywhere. Now what happens, even though everything is perfectly sealed, it's always perfectly sealed with weather-tight arrangements and all, there is always a minute element that there may be some salt present, and if any penetration comes, okay, this question is, somebody is saying ships are electrically grounded. Yes, because you are in water. Salt water is a conductor. Ship is made up of metal. So ship is automatically grounded. Now this problem comes up of electrical grounding when we go to dry docks. Now in dry docks, what happens is you remove the conductive material. Ship is metal. Now, okay, ship is painted. Paint is sort of insulation. But one way or the other, the current is going to find way to neutralize. What is earthing? Earthing means the excessive current which is present has to be neutralized. That's why we call it earthing. Ships are grounded. Dry docks, when you go in dry docks, first thing that happens, is you are still waiting in forward and aft mooring stations. Ship starts going down because as the water is pumped out, ship is going to sit on the bottom. By that time, somebody is going to come from ashore. They have got ways and means. They have got their cranes working as elevators and all. So they are going to get somebody, and the electrical connection is going to come, and it will be grounded on the ship. Ship's body will be grounded in dry dock. Then only all water is removed. It is done as an automatic process by shipyards, but this is a very good question because ships are grounded all the time. Okay, so what happens is there is a possibility. So what happens generally if there is a fire? We first switch off all non-required electrical connections first before we start tackling. That's the first part, because engine room you will be still present when you are using hypermesh, possible. You are there and a fog-like thing will be sinking on it, cooling everything. It's very much possible. But hypermesh systems are also not allowed to go on automatic. It's manual. Then you have got high expansion foam system. Now, high expansion foam systems are two types of deliveries. Foam is same. Acha, this electrical grounding, Udesha, you got it, na? Okay, fine. Now, high expansion foam. Now, always remember when we are deciding on this, the medium is one thing, delivery system is something else. Now, how do you create the medium? Because some mediums can be used directly like water. There is no processing of the medium. CO2, there is no processing of the medium. Whereas foam, it is processing of two components to produce the medium. So that additional part comes in. So, learn to break it in parts so that each part can be explained easily, each part can be remembered easily. So like high expansion foam, you get two types of delivery systems. One is you locally make it, other one you bring the foam and deliver it there. Two things. Same thing, I don't know if you're used to it. Some, these attempts were made some time back in cities that ice cubes were delivered at home. You could phone up and guy will bring ice cubes. Kitna kilo chahiye, you use it. Other one was you put it in the fridge and then you take out one by one. So like that. Then foam movement we talk, you have got basically three types of systems. Fixed high expansion foam, which is not for open areas. It is meant for enclosed compartments. Medium foam on deck, on tankers. And low expansion foam is used in engine room if at all. Generally, you will not find it anymore. But you should know it. Percentages of foams. So like your answer should be well structured answer. Inert gas system, of course, there is a sort of a clash. You get two types in the sense, two types in teaching. I taught you something, I use block diagrams. You also get it taught by Ram Lakhiani sir. Now he talks more from engineering angle. Okay, so just remember, you have to know the principle for this paper. Block diagram, then inert gas has got two areas. Okay, flammability diagram. Next time, okay? Next time we'll do. That's okay. He is teaching you from that angle. Now, coming back to this thing, the inert gas has got two areas, okay, that you have to show demarcation. That means you have to draw one line, so this is the hazardous area, non-hazardous area, then put the components there and the linkage. Most important thing that you must remember always when you write any answers, ships operate in temperatures of -25 to plus 50 degrees. It's a big range. All our systems must function in those temperatures. Ships are susceptible to very bad weather. That means there can be rain all the time, heavy rains. Still the system must function. Okay. So the freezing cold also system has to function. That means if you are using water, like you use something water on inert gas system, or like foam systems, some of the areas where you got a foam generation system. So all those places you need heaters also. So on that sort of a thing, general knowledge you have to use when you are writing these answers. That assume if it is cold, then what is the precaution against that excessive cold? Yes, the heater should be provided. Very good. Your answer is perfect because that is how the ships were. Like lifeboat engines also have got heater circuits. And in cold climates, we plug them in. And only when you want to launch lifeboat, you unplug it. That means engine was kept warm. So that is the way it is. Then international shore connection. It is a standard one. You have got everywhere. Again, it is a mugging up. So, okay, we'll stop here. You all are already fed up and some of our brothers may not be around from what storm hit areas. Even though we are 60 to 65 तक पहुंच गए थे, अभी वापस थोड़े कम हो गए. I don't know what happens. Huh? Okay, I'll stop the recording.